Welcome to Understand the Math. Suppose a rock is launched vertically upward from the ground with a speed of 96 feet per second. Neglecting air resistance, the position of the rock is given by y is equal to minus 16t squared plus 96t. I've graphed this function down below. You can see that the rock starts on the ground, goes vertically upward, reaches a maximum height, and then comes back down. We're going to find the average velocity over these given time intervals. Here's our first interval, second, third, fourth, and fifth intervals. Notice that in each of these intervals, our time starts at 1. After we find the average velocity, we are going to estimate the instantaneous velocity when t is equal to 1. We're going to place our point P when t is equal to 1, so that's right here. And then if we look at our time intervals, our first interval goes from 2 to 1 all the way down to our last interval, which goes from 1.001 to 1. So let's go ahead and put point Q on our graph, and we'll put it when t is equal to 2, because that's our first interval. Our average velocity then is going to be the slope of the secant line, and then our instantaneous velocity is going to be the slope of the tangent line at point P. I'm going to write a few things down right here beside our graph because I think it's going to make a little bit more sense. Our time is going to go from T1 to T2, and we're going to let T1 equal 1. I think that's a big point of confusion for students. And then we're going to let T2 vary. So we're going to set that equal to t. We can then write that our average velocity is given by the formula s of t2 minus s of t1, all divided by t2 minus t1. I think it's always good to write down the formula just like you've memorized it. Now we're going to make a change. Our s is our position, and our position in this problem is given by y. So we're going to write this as y of t2, which we just said was t. So this is y of t minus y of t1, which is 1. All divided by t2, which is t, minus t1, which is 1. Our instantaneous velocity is then going to be the limit from t2 to t1 of our average velocity. So this is just going to be the limit as t goes to 1, making that change in notation, of our average velocity. Since we had to continue onto this page, I've rewritten the problem just to make things easier. Let's go ahead and let's highlight that this is what y is going to equal, because we're going to need that. We're going to start with part A. We've already talked about it, so we know what we're going to do. Let's just go ahead and now write down our formula that we had from the previous page. We found that the average velocity was y at t minus y at 1, all divided by t minus 1. Now we're going to plug in what this is. Y at t, looking at our formula highlighted in yellow, is minus 16t squared plus 96t minus y at 1. So this is minus 16 times 1 squared plus 96 times 1. And we're going to divide all of this by t minus 1. Now let's go ahead and simplify. This is minus 16t squared plus 96t. We have a minus a negative, so that's a plus 16, and then we have a minus 96. I want to point out this negative right here. The biggest mistake I see students make is to not carry that minus over to both terms. And all of this is divided by t minus 1. Simplifying further, this gives us minus 16t squared plus 96t minus 80. And that's all divided by t minus 1. Now we need to factor this quadratic. Notice that 16 is common to all three terms. So I'm actually going to take out a minus 16. So we get t squared minus 6t plus 5, because 16 times 5 is equal to 80. And our denominator stays the same, t minus 1. Now we can go ahead and factor. This quadratic factors as t minus 1 times t minus 5. And you can see that our t minus 1 terms are going to cancel. So our average velocity becomes minus 16 times t minus 5. And that's equal to minus 16t plus 80. Let's highlight that because that's what we're going to use for our formula when we compute our average velocity in all 5 of our intervals. Our first interval is from 1 to 2. So we're going to let t equal 2. So our average velocity is just minus 16 times 2, just plugging into our formula highlighted up there in yellow, plus 80. This is minus 32 plus 80. So we get a value of 48, and we always need to put our units in. Our average velocity is going to be feet per second because it was delta y, which was in terms of feet, divided by delta t, which was in terms of seconds. Now let's look at our second interval. It goes from 1 to 1.5. So t is 1.5. Our average velocity is then minus 16 times 1.5 plus 80. You can throw that into your calculator, and you would get a value of 56 feet per second. Let's now look at our third interval. It goes from 1 to 1.1. We're going to do the same thing. T is equal to 1.1. Our average velocity is then minus 16 times 1.1 plus 80. And this gives us an answer of 62.4 feet per second. Hang with me, we just have 2 more intervals to do. Our fourth interval, we're going to go from 1 to 1.01, so we're getting a lot closer to 1. T is 1.01, and our average velocity is minus 16 times 1.01 plus 80, and this gives us a value of 63.84 feet per second. Now let's look at our last interval. This is from 1 to 1.001. Our t is 1.001, and their average velocity is minus 16 times 1.001 plus 80, and we get a value of 63.99 feet per second. Let's go back up here and let's highlight these answers. Here's our first one, second one, third, fourth, and fifth ones. Now, what we're going to do is estimate the instantaneous velocity when t is equal to 1. Our formula is v is the limit as t goes to 1 of our average velocity. When we look back up and look at our answers that we highlighted in green, we have to find our limiting value. As you look at those numbers, can you see that they are getting closer and closer to 64? So that's actually going to be our instantaneous velocity. So our instantaneous velocity is going to be 64 feet per second.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.